Review radicals and exponents. Okay, he has a confused look. Reminders. 5 to the 0 is, anything with 0 power is? 1. Right. I always hear someone say 0. How'd that happen? Zing. 1. Oh, whoa, where'd that come from? Where'd the other guy go? Oh, there it is. Hey, there you are. Yep, what? You get back up there where you belong. We'll bring that one down. There we go. Go with your friend there. There we go. Got it. This is 1 over 5 squared. Negative exponents send things either to the denominator, or if they're in the denominator, they go back up to the top. So that's 1 over 25. Ooh, this is a tricky one. Trying to confuse you here. 5 to the 4th times 5 to the 5th is 5 to the 9th. It is not 25 to the 9th. That doesn't make any sense. Because this is 1, 2, 3, 4, and then this is 1, 2, 3, 4, 5. You have a total of 9 5s. You don't have a total of 9 25s. That makes sense to you guys? See it when you write it out? It's 5 to the 9th, not 25 to the 9th. That's probably the most common mistake on that one. A power to a power, you multiply. That's 5 to the 12th. So when you multiply, you add the powers. When you raise a power to power, that's when you multiply. Because you have 4 sets of 3. 4 sets of 3 is a total of 12. This one, these 3 cancel out 3 of those, leaving 5. So it's 5 to the 5th. You can subtract. 8 minus 5 leaves you 3. Questions on that slide? Reminder, it says you cannot have negative exponents. Technically you can, but we don't like you to leave stuff with negative exponents. To change a negative exponent to a positive, you just move the exponent and the term it is attached to. Example, 6x to the negative 3, that's 6 over x to the 3rd. We don't like it left as 6x to the negative 3. Send that negative to the denominator, make it positive. This one, 5x to the 7th over 6. That negative is in the denominator, so we're going to send it to the numerator. Suppose I should be looking at this in Zoom entire page. That's probably how it was written. More examples. We don't want to leave this one. We don't want to leave this one. So they're going to go, that one's going to go up there. This one's going to go down there. We have 3x squared z to the 5th over 7y squared. So nothing moves except for what has the negative exponents. So I don't move the 7, I don't move the 3, I don't move the x squared. Oh, watch that. Oh, that's crazy. Everything gets moved down. But 2 times 9, that's going to give you 18. It's multiplication when you move it down. And then we have x to the 3rd, y, z to the 4th. Everything ends up in the denominator. When that happens, there's a 1 up there. There'd be a 1. What? Oh, for crying out loud. You're exactly right. That's a 4. Shame on me. 36, right? 4 times 9, 36. I wondered why you're looking at it like that. Because I made a mistake, that's why. Simplify. Use only positive exponents. Multiply 10. 3 plus 9, 12. There we go, 10x to the 12th. When you multiply, you add the exponents. This one, 5 to the 4th. I don't know what. 625. I don't have that one memorized. 625, w to the 4th, y to the negative 8th, z to the negative 12th. So power raised to a power, that's when you multiply. But it says don't use negative exponents. So now we have 625, w to the 4th over y to the 8th, z to the 12th. The only things you move are the ones that have the negative exponents. Questions on that one? Lots of little examples today. Simplify, use only positive exponents. So now 5/10 is a half. Now that doesn't, just because we have variable doesn't mean that changes how we simplify fractions. So 5/10 is a half. These 5 are going to come up here and join those 2, which makes x to the 7th. We're going to add those together. Add the powers anyway. And then these are both exactly y to the 4th, so those cancel, and we have our final answer right there. That's all you can do with that one. This one, here's what I would do. I would do power to a power, -6, that's 10, that's 10, and that's 4. Power to a power, you multiply. Now we're going to deal with the negative exponent. So 6 goes down the bottom and joins with 10 and makes 16. 4 of those b's are going to cancel. So these 4 cancel out 4 of those, leaving 6. So you have b to the 6th on top. So b to the 6th over a to the 16th. That's what I get for that one. Questions on that slide? Let's keep rolling. What's anything to the 0 power? 1, not 0, it's 1. So it's 1 over 4 d squared g to the 5th. I don't even care what we're raising to the 0 power. It doesn't matter, it's all 1, all of it. All right, how about 144, 12 squared, x to the 4th, y to the 12th, over 8x to the 4th, y to the 7th, so far. So I took care of the squared. Power to a power, you multiply the powers. 118. 144 divided by 8 is 18. The x to the 4ths, they cancel. And 7 y's are going to cancel. That's y to the 5th. I don't need the bar because everything in the denominator went away. That's all gone. That's it.